I think I was going through binary. Yeah. Yeah. Oh, yeah. All right. IntelliJ. Oh shit, I'm tired. All right. All right, this could be a good session. Timer's going. All right. Okay, well, 6 would be like 1, 2, 4 plus 2. Okay, so this is 6, right? So 6, 6, and 6. It's one of these three. 11 would be 8 plus 2 plus 1, which is 1, 2, 4, 8 plus 2 plus 1. So it's this one or this one. All right. And now 23, this one doesn't have enough, so I think it's that. Convert 93 to binary using the method of your choice. So it would be 64 plus what, 16 would be 70, 80. This would be 80. That was 64 plus 16. So then we got to go to 88, right? That's 88. And then we need 2. We need 3 more, right? What was it? 93. So hold on. This was 70 plus 10 is 80. Yeah, so 88. So I would need 4. $88. Yeah, it's 4 and 1. So it's 88. 92 plus 1. So 0, 1, 0, 1, 1, 1, 0, 1. I think it's this. Nice. Decimal to binary with Python function. Why am I doing a what? Why? Okay, so it's just 13. 1, 2, 4, 8. So I need 8 plus 4 plus 1. So it's this one. Okay. Um, 7-bit encoding. First, computers started to use 8-bit sequences, bytes, for storing information, and ASCII strings had extra memory that wasn't being used. Second, and most important, 128 symbols just wasn't enough for everyone, not even for the English script itself. English script? English language? English script, the written language. Whatever. There was a clear need for new improved encodings, and many of them started to appear after ASCII. There were extensions of ASCII or encodings for specific scripts. For example, Windows for Cyrillic. However, in different encodings, the same number could represent different symbols, and that would complicate communications. The solution to all these problems had to be a unified system, and that is when Unicode comes in. Unicode is a standard for encoding and representing text. It is not an encoding per se, since it doesn't determine how symbols are converted to bytes. It is simply a specification that defines the mapping between symbols and numbers. The Unicode standard was proposed in 1991 by the Unicode Consortium. As the name suggests, Unicode was intended as a universal standard, and it's safe to say that now it is. Unicode can also be viewed as an extension of the ASCII table. In fact, the first 128 numbers in the Unicode represent ASCII symbols. All in all, Unicode can accommodate 1 million code points, but as of May 2019, only 100 and whatever are occupied. The fact that most code points aren't designated yet is also one of Unicode's advantages. Yeah. Oh, God. Okay. Unicode consists of two parts: Universal Character Set, UCS, and Universal Transformation Format, UTF. Oh. Okay. I've seen UTF before. UCS is essentially an index of all symbols supported by the Unicode. I feel like this is all stuff I've touched on before, but I've never really committed any of it to memory. This is kind of interesting. In Unicode, every symbol corresponds to a number. A code point is usually presented with U plus following, the hexadecimal number in the code has from 4 to 6 digits depending on its place in the standard. For example, the code Latin letter Q is okay. Oh, sick. Okay, that's what they are? Wait, let's read this. By looking at the table, you can see that Q is at the intersection row of that, which is where the code number comes from. Most Unicode codes can be either transformed into HTML codes. You just need to convert the hexadecimal number to decimal and write it in the HTML format. The HTML code for the letter Q is then that. You can check if hexadecimal 51 equals decimal 81. Unicode code points are divided into 17 planes with numbers from 0 to 16. Each plane is a continuous group of 65,000. Okay. The plane with the number 0 is called Basic Multilingual Plane, BMP. The ASCII part of the BMP includes the first, supplementary planes. Encodings describe how symbols, or rather their code points, are transformed into bytes according to a particular character set and vice versa. There are several UTF encodings, but the most popular are UTF-8 and UTF-16. That's for how many bits? Bytes? How many bytes? How many bits? One to 4 bytes. How many bytes? Consider the following Unicode code points written in hexadecimal format. What do these hexadecimal values signify in the context of Unicode encoding standard, and how does Unicode differ from other? These hexadecimal code points indicate byte values as part of These code points are from a Unicode character set with a limit of 108. And how does Unicode differ from other encoding systems such as ASCII? I feel like it's one of these two. The double liner? Yeah, okay. Unicode points are written using U plus following a hexadecimal number. What is the minimum amount of symbols? Which encodings support the entire Unicode TF16? What? Okay. Fuck is my... I guess it's recording no matter what. So I've been having Wi-Fi issues all day. I don't know what's going on, but it's recording either way, so I think we'll be good. IntelliJ. No, Firefox. Okay, we've encoded a word using this part of the Unicode. Your task is to decode it, please. Oh, jeez. Is it Unicode? There's no input. What? You see this? Oh, no. Oh, fuck. Come on. There we go. 0048 HELLOWORLD. Fuck. All right. It was worth a shot. 7 and 9. What? What was the first one again? 048. Oh my god. H, right? Then 7, 9. Y. 70 P. Or skill. Nice. W 0057. One of these two. Nice. And then Wharf WOR. O. O is 6F. This one. Pairs. I saw pairs. Character encodings may form a certain hierarchy in terms of which parts of the Unicode character set they can represent. Below are some symbols with their code points. Match the symbols to the minimal encoding that can be used to represent them. Match the items from left and right columns. What? Match the symbols to the minimal encoding. I don't know what this is asking me, really. We'll do this, though. What the fuck? Okay. Should we do this? JRE does not equal JDK. The Java, I don't remember what JRE even stands for. Come on. There is no link to the theory. That's super frustrating. What does JRE include? Probably the Java virtual machine and a compiler. I guess not. The class library and JV. What does GUI stand for? Sure. Oh, almost. Oh, close one. What is a command line? A way to interact with computer via text commands with computer. Have we named it computer? Shouldn't it be capitalized then? Way to interact with the operating system. No, a program written on open. You have moved to the parent directory. You have moved to the root directory. You have created a new folder in the current directory. I think it's that. If I cd slash cd it might be root. I think it might be root. Yeah. Where the state of an object is stored. Friends. Alright. Time to work on the project. Let's solve an IDE. Cool. So, what do we got to do? In this stage, you'll learn how to convert each character of a string into a binary format. Any ASCII character has a size of 7 bits. In binary, the form is 0 and 1. For example, the character A has a decimal value of 65. The binary representation, sure, B is 98 and 98 in decimal, okay. In this stage, you will learn to represent characters in binary form. Read the string from a console. The input contains a single line. Print the result. Note the binary representation must be 7-bit. Got it. So, kind of a weird setup, right? We're going to want this fun get char. And now yeah, right? Okay, so I mean, if I had to do this myself, we would say let's see, ch.to first off, maybe we go string, and then there's a lot of stuff here. To unsigned byte, right? Uh, Come on. So any ASCII character has a size. Is there anything else? Integer to binary string. What's this do? What? What does this do? Why is it in my val encoded equals, and then let's just print line encoded. Let's get rid of this for a second, and then we'll instead of this, instead of joining to string, we'll dot map character string get as binary character. Okay, let's just make this string for now, and then return that. Now what's the problem? What can it possibly complain about? Required string, got it. Got it. had before. Okay, characters, so we change this, and then let's do a characters dot for each. Yeah. Character string get as binary character. What does that tell me? Let's see. Yeah, I don't know. I don't know where this ASCII encoding is, dude. It's like, come on. You'll learn how to convert. I'm not going to count. What is going on here? A has a decimal value of 65. Like, how does that help me? What? Damn, dude. Fuck. Fuck. And this shit's not working either. Here we go. Oh my god. It just literally doesn't work. I don't understand what's going on. Oh my god. Wow. Wow. It's just like, wow. What the fuck, dude? Oh my god, dude. What is wrong? Literally can't click on anything. Fuck. God fucking damn it. It's so annoying. See, it's like, why? So val decimal val equals ch.code. Okay. So now we need to convert it, right? We would do decimal value list of int. This is how you. Yeah, we could do it like this. I know what to do. How do I do this? Oh, I guess we don't need this. Okay, so you go backwards, right? I guess you don't really have to. You could do, and at the same time, okay. At the same time, you can go the other way to, what's that, 100? 1,000. Okay, so basically what you can do is what I've been doing by hand. And now, like if I add 10 and 1, right, I get 11 there. And that's exactly what I want. So now, and you would always add the largest possible one. Okay, so now val, what is it? Des equals list of, and you do 64, 32, 32, 16, 8. I'm like looking at the 4, 2, 1. Right? Okay, so now we have the decimal value. Here, I think I could even, there's no need to declare these multiple times. Des, is this, okay. So now, var cur equals decimal val, while cur is greater than 0, right? Then, okay, and now we do, oh, and then var output equals 0, right? And then you would do for d in des, can I do d in des b in bin? No. So then I in des size. now I can do d val d equals des dot get I, and val b equals bin dot get I. Okay, so now we have each thing, and we can finally just say if cur is greater, no, if cur minus d is greater than 0, then cur minus equals d, and output plus equals b, break. Okay, why do we break? Is there any reason to break? I'm actually not sure there is, right? Because the max value, in fact, maybe I don't even need the while loop, right? Like 32, let's think about it, right? Like if we can do 64, there's no way we can do 64 again. We would have to go to 32. So maybe we don't need this at all. We can save ourselves some headache. And then this should just return output dot to integer. Gets me every time. Oh my god. Let's just see if this works real quick. Okay, so we'll keep this as string. We'll make this string. And then we need, how do I coerce string? Oh no. Maybe it's ch. Can I just get a 2 character? Why does it have to be an array? Oh my god, dude. String to char, Kotlin. Huh. Fuck. I'm not gonna finish because I literally can't load a website. Like, I don't fucking understand. Thank you. All day it's like this, dude. What is going on? Single. Okay. It looks like we have have something going here. So now let's look at it. Well, I guess this is going to print, yeah, the output of analyze. All right. Try again tomorrow. Fucking week. Anyway. Nice work, team.